Hi, my name is Terry, and in this video we're going to look at an example of a triple integral. Over here on the screen you can see a little explanation of how to set up a triple integral. Triple integral is a function of three variables, x, y, and z. So you have the dv, v for the volume because you have three dimensions, x, y, and z involved, so you're going to have the volume component. So when you're setting up your triple integral, the inside bounds can be up to two variables for the inside bounds, up to two variables. Your middle bounds can be up to one variable when you set it up, and your outside bounds are constants, okay? So that's what we're going to look for when we're setting up our triple integrals. We're going to look for, this will help us when we're having to generate and put it together, when we're doing which set of bounds would need to be where. Okay, so because we're going to have to figure out the order that we're going to integrate with, we have three variables involved. We have an x and a y and a z. So do we integrate with respect to x first, then y, then z? Or do we x, then z, then y? Or maybe y first, then z, then x? Or maybe y, then x, then z? Okay, we have other options too, right? We could have z first, then x, then y. We could have z, then y, then x. I think that covers it. So. But we'll have options, so we'll have to just see. It's going to be based on what we're given, and it's going to be looking at the base. So let's take a look at our example over here. We want to evaluate a triple integral. The integrand is x times y, right? So the integrand is x times y, and it's bounded by y equals x squared, x equals y squared, z equals 0, and z equals x plus y. So right here, taking a look at this, I know that my inside bounds, because my z's are up to two variables here, my z is two variables, my inside bounds are going to need to be the z bounds for this one. So I will be integrating with respect to z first, okay? Now, what about the middle and the outer? Well, I'm going to have options there, okay, because of the base. So we're going to start. Let's go ahead and sketch this base, all right? So let's go ahead and take a look. Let's sketch what does this base look like, all right? Because that's going to determine which order I'm going to set this up, all right? So here's my base. My base is just, I'm just dealing with the x, y, so I'm going to just draw a two-dimensional, okay? And so you have y equals x squared. So now y equals x squared, remember that's your parabola, sits on the origin, okay? And then x equals y squared is also a parabola, okay? Hits the origin, but it's going to open to the right. So when I take the parabola here that opens up, parabola that opens to the right, this is my base. This is the region. It's the overlap that I'm looking for right here, all right? So I have my parabola that opens up, okay? This is my y equals x squared, all right? And then I have my parabola that opens to the right, and this is my x equals y squared. All right, so here's my base. This is the base that I'm dealing with right here. All right, so you can see how that was generated with these pieces. All right. So we want to, because we have options as to how we set it up. So let's write each in terms of, so x equals y squared. Well, if I take the square root of both sides, I can say, well, that means that y is going to be the radical x over here. Okay, and then down here, let me take the square root of both sides here, and I can say x would be to the radical y, because we're going to try to figure out how we're going to set this up, a type 1 or a type 2, so we may want to see these both ways, all right? And we also will be needing the bounds, okay? We're going to need to know what the boundaries are from left to right, up, down, okay? So we need to know the points of intersection, all right? So you can solve for it, maybe you can eyeball, see what it is, but if I'm going to solve for it, maybe I'm going to take y equals x squared. So let me take the y equals x squared and y equals radical x. Since y is x squared and y equals radical x, I can set these equal to each other. All right, if you square both sides, to remove the radical, you can square both sides. Subtract x from both sides, so x to the fourth minus x gives me 0. Factor out the x, okay? So your x bounds of integration are going to be 0 and 1. So those are the x bounds of integration. All right, so this would be at the origin 0, 0. This is going to be at 1. When x is 1, y is the square root of 1, which is 1. So you can plug it back in. So 0, 0, 1, 1. So now we have the boundaries written every which way. We have the boundaries of the curve. So let's go ahead and see how we set this up. Okay, let's go ahead and set up our triple integral, and then we'll evaluate it. Okay, so this triple integral right here. Right, so we're going to set up our triple integral. The inside bounds, okay, well, let's start. Let me write x times y. All right, that's what the integrand is, all right? The the inside bounds up to 2 variables, and because z is presented this way, we're going to integrate with respect to z first, okay? And then the inside bounds, we're going to let the inside bounds go from 0 to x plus y, right? Just because of the way it's presented to us. Now to deal with dy, dx, dx, dy, what do we want to do next? Okay, here's where we have to go back to the way we set up double integrals. We want to take a look at, do we want a type 1 or a type 2? And you could, either one would work here. Okay, so either way. So say we want a type 1, let's say we want a dy and then a dx, okay? So if we want to do the dy, then the dx, okay? So then our inside bounds would have to be y equals as a function of x. If we're going to integrate y next, okay, inside bounds would have to be y equals as a function of x, and you would go from the lower, okay, y equals as a function of x to the upper. That's why I wrote it this way, okay? So so your inside bounds, we're going to integrate with respect to y next, okay? So then your inside bounds would need to go from x squared to radical x. They would need to go from x squared to radical x for your inside bounds, all right? And then your x, okay, then this dz, dy, okay, so then the x bounds, okay, the x, well, we took care of the type 1, so x squared to radical x for the vertical. Now the horizontal, you just look at the x coordinates because we're moving horizontal, so 0 to 1, so 0 to 1, all right? And so this is how you would set it up, okay? So how you would set it up, so you set up a triple, inside bounds, function of 2 variables, all right? And then your other set of bounds, you do have options, okay? dy, dx, you could also do a type 2, okay? We're going to solve this one, but just so you can see what a type 2 would look like, okay? You could also set up this way. The inside bounds are going to go from 0 to x plus y, all right? And then it's x times y for the integrand, okay? You're going to integrate with respect to z first, all right? But instead of dy then dx, you could do the dx then dy, okay? So it is possible. If you wanted to integrate with respect to x, dx, then dy, you'd have to set up a type 2, okay? So type 2 means your inside bounds would have to be x equals as a function of y, so you would be going from here y squared to radical y, okay? You would be going from y squared to radical y. All right, and then your outside bounds, y equals bounds, well, it would also be 0 to 1 because it would be representative of the y coordinates there, which are the same as the x, so 0 to 1, all right? So whether you go through and solve this, all right, or if you go through and you solve this one, whichever one you work through, you're going to get the same answer, okay? I'm going to move this out of the way, all right? So that it's just another way to set it up, all right? Because you do have options sometimes when you're working with a triple integral. Okay, so solve an iterated triple integral. How do we solve an iterated triple integral? The technique is exactly the way you would with a double. You're going to work from the inside to the outside. We're going to go ahead and take care of the integration with respect to z first, okay? So 0 to 1, and then x squared to radical x. We'll come back and get to that. Integrate with respect to z, x and y held constant. So when you integrate x times y with respect to z, you're going to get x times y times z. And now we want to evaluate this from 0 to x plus y. Okay, we'll come back and take care of dy, dx momentarily. Okay, so we have the outside bounds that we'll get to. Okay, so now let's go ahead and fundamental theorem in calculus. So you're going to plug in the upper bound for z. Remember, whatever you integrated with respect to the variable, that's what you're replacing the variable with. So we have x times y, that's going to be multiplied by z that we're substituted in the x plus y, okay? Plug in the lower bound, you're going to get 0 when you plug in the lower bound, all right? Now, before I go ahead and integrate this, I'm going to expand it. Let's go ahead and multiply this out. So integrate from 0 to 1, x squared to x, radical x, okay? What do we have here? When you distribute x times y times x, this gives me x squared y. And when you distribute over here, this gives me xy squared, okay? All right, now let's go ahead and integrate with respect to y next. With respect to y, x is held constant. We're going to integrate with respect to y. Integrate with respect to y, this first term becomes x squared times y squared over 2. X squared's a constant, just bring it down, integrate the y squared over 2, all right, and then integrate xy squared. X is the constant, just bring it down, xy cubed over 3. We want to evaluate this from x squared to radical x, okay, and then we'll integrate with respect to x, all right? So we have from 0 to 1. Plug in the upper bound, radical x, you're going to plug it in for y. Y was the variable, so plug it in for y. So when we plug in the upper bound, radical x squared is x times the x squared here, x cubed over 2. Plug in radical x here, radical x, so you take the square root of x to the third power, that's x to the 3 halves. X to the 3 halves times x to the first gives you x to the 5 halves power over 3. Okay, so here's plug in the upper bound, minus, now we need to plug in the lower bound for y. Plug in the lower bound, when you plug in x squared squared, that's x to the 4th times the x squared that's here, so x to the 6th over 2, okay, plus. Plug in x squared for y here, x squared cubed, so that's x to the 6th times the x out front, x to the 7th over 3, all right? And we want to now evaluate this quantity with respect to x. These terms do not combine because the exponents are all different, so let's go ahead and integrate this with respect to x, okay? All right, and I am running out of space, so let's do the best we can here with the space we've got, okay? So with respect to x, let's go ahead and integrate. So the first term gives us x to the 4th over x to the 4th over 8, 4 times 2, okay? Plus, this term here, we have the 1/3. I'm going to bring the 1/3 out front. All right, so we integrate x to the 5 halves. That's going to give us 2 sevenths x to the 7 halves. Okay. Then we're going to subtract to integrate x to the 6th. Okay, so that's going to give us subtract x to the 7th over 14, because over 7 times the 2 that's already there. And then distribute the negative sign. So subtract and integrate x to the 7th. You're going to get x to the 8th over 24. Okay. This is going to be evaluated from 0 to 1, all right? So let's plug in the upper bound, plug in 1 gives us 1/8, okay? Plus, plug in 1, you get 2 over 21, okay? Minus, plug in 1, you have 1/14. Plug in 1, you have 1/8, okay? When you plug in the lower bound, you do have 0, all right? And then, 1 over, I'm just noticing this, okay? 1 over 24, okay? So when you plug in 1, you have 1 to the 8th over 24, okay? So 1/8 plus 2 over 21 minus 1/14 minus 1 over 24, all right? So that's what your answer is, okay? All right, so can we write this, get a common denominator, write this as 1 fraction? Sure, you could do that, okay? You could do that, and when you do get a common denominator, write it as 1 term, as 1 fraction, you end up with your final answer in reduced form as 3 over 28. I've already taken the technology ahead of time and computed this, okay? So 3 over 28 would be, and you can check that over, okay? But 3 over 28 is the final answer here, okay? So this video just wanted to show an example of how to set up and solve an iterated triple integral. Hope this helps. Thank you for watching. Stay safe, stay healthy. Thank you again.